In the previous lesson, we focused on graphing from the equation of a transform sine or cosine function. So in this lesson, we're going to go backwards, okay? So last time we went from equation to graph. In this lesson, we're going from graph to equation. Now, before we go from graph to equation, we'll just do a few practice questions just to make sure we're ready to extract information from the graph. All right, so write the equation for the sine function that has the following properties and state the range of each sine function. Okay, so the amplitude is 3, the period is pi, no horizontal shift or vertical shift. So that's basically saying the magnitude of A is equal to 3. What about the magnitude of K? Well, that's 2 pi over the period. So 2 pi over pi in this case. So the magnitude of K, or the absolute value of K, is 2. So I got A and K, I got 2 more parameters to go. D is 0, C is 0. So let's write the equation. And they want sine. So f of x equals 3 sine 2x. So just like what I said last time, there are 4 possible equations you can write. You can make A negative and you can make K negative, because by making A negative or K negative, you won't change the amplitude, it'll still be 3, and the period will still be pi. But I'm just going to leave A and K positive. Alright, so this time the amplitude is 4, so the magnitude of A is 4. The period is 2 pi. That means the period is unchanged. So that basically says that the magnitude of K is 1. There's a shift of pi over 3 radians to the right. So D is equal to pi over 3. And there's a vertical shift 2 units up. So C is equal to 2. So f of x equals 4 sine x minus pi over 3, because it's x minus d, so it's minus pi over 3 plus 2. Okay, so far so good. So now we're going to do the exact same thing, but instead for cosine. So the magnitude of A is 2. Ooh, the period is 3 pi. So the magnitude of K is 2 pi over the period. So it's 2 pi over 3 pi. So the magnitude of K is 2/3. No horizontal shift. The vertical displacement is 1 unit down. So C is -1. So f of x equals 2 cos of 2/3 x minus 1. Alright, one more to go, and then we'll do the fun stuff. So amplitude is half, so the magnitude of A is half. The period is 2 pi, so the magnitude of K is 1, because the period remains the same as it was before. Shift of pi over 2 to the left, so it's negative pi over 2. C is 3 because you shifted 3 units up. So what's the equation? F of x equals half cos x plus pi over 2 plus 3. Okay. So these 4 questions are very useful, because what we're going to do is we're going to extract the 4 parameters from the graph. We're going to figure out what A, K, sine equation. Okay, so I'll let you choose which one you want to do first. So you could choose to do sine or choose to do cosine. It doesn't really matter. You know what? I'm gonna choose, actually. I thought I was teaching my class, but this is gonna choose sine. I would argue sine is a good idea. Okay, so why is sine a good idea as opposed to cosine? Not that you can't do it if you chose cosine, but because I can see the equation on the axis. So the maximum value for this trig function is 1. And the minimum value for this trig function is -3. So the middle, you can average 1 and -3, but you'll get -1. Okay? Ooh, that was not pretty. It's okay. Okay, so that's the equation of axis I drew right there. Okay, you can even write it out. Y equals -1. I'll show you how I got -1 afterwards, but it's very obvious it's -1. So I think it's a better idea to do sine instead of cosine first, because if I choose to visualize this graph in terms of sine, I don't have to start away from the y-axis, because on the y-axis, the y-intercept is actually a point on the equation of the axis. It's on the middle of the wave, so it's very easy to visualize it in terms of sine as opposed to cosine. So what I'm going to do is I'm going to sketch in one cycle. Okay, I want one repetition of the pattern. Okay. So what can I extract after I highlighted one of these cycles? So A is equal to the magnitude of A is equal to max 1 minus -3, max minus min over 2, so it's equal to 2. What about K? K is equal to 2 pi over the period. What's the period? Well, when did I start highlighting or start drawing with my purple pen? When x was 0. And I stopped drawing at 2 pi. So from 0 to 2 pi, that means that's how far I have to travel horizontally to complete one cycle, which is the definition of a period. So this is 0 to 2 pi. This horizontal distance is 2 pi. So the period is 2 pi. So 2 pi over 2 pi is equal to 1. Nice. Now I'm not going to do D. Okay, we'll save D for the very end. So C is equal to max plus min divided by 2. Hey, what do you know? -1. That's what we said earlier, right? See? -1. Equation of the axis. You must have shifted 1 unit down. So D, why did I not write D here? Because you need all 4 parameters. Because D depends on whether you visualize it in terms of sine or cosine. Okay, so since I started highlighting or drawing with my purple pen when x was equal to 0, when I started on the y-axis, that means there is no horizontal shift. Okay, there is no horizontal shift. So my first equation is f of x equals, now look at this beautiful purple cycle here. This is how the regular sine wave looks like. It goes max, then min. So it's going to be a positive 2 here. Sine, and then x, oops, let's keep it simple, just sine x, no brackets needed. Sine x minus 1. Okay, so now I'm going to highlight using a red pen. So this one is going to be a cosine wave. Now cosine, you can start at a maximum point or a minimum point. So I could choose to start here, 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 or here. Okay. Now saying that, I have, what is it, 2, 4, 6, 8. I have 8 potential starting points. I would argue it's very silly to start over here. Is it wrong? No. Can you do it? Yes. But it's pretty silly. Why go so far when you can start a little closer? So for all the questions, when I choose my starting point, whether it's sine or cosine, I'm going to pick the point closest to the y-axis. Okay, so I'm going to pick this point right here. Okay. So this is another reason why I did not indicate D here. There's no calculation for D, because D, I can extract that information just by using my purple and red pen. So I'm going to write g of x equals, so this time look at my red pen. This is not the normal cosine wave. The original cosine function starts at a maximum point, but this one starts at a minimum point. So it should be, there must have been a reflection across the x-axis. So you write -2 cos. The beautiful part about this, a, k, and c, they're exactly the same. Whether I choose to visualize this function in terms of sine, using a sine wave or a cosine wave, the amplitude's not going to change. The period's not going to change. The vertical shift is not going to change. Right? The only thing that is changing is where you choose the beginning of your wave to be. So the only thing that's going to change is the horizontal shift, the d value. So if I choose here, that means I used to start on the y-axis, but if I start here, that means I must have shifted pi/2 to the left. Boom, done. Okay. All right, so this one, I'm going to start with cosine, because if I do cosine, I don't have to introduce the horizontal shift. So I'm going to stay consistent. Cosine is red and sine is purple. So sketch one cycle, one repetition of the pattern. There you go. And from that, I'm going to extract what A, K, and C is. So the amplitude is max minus min over 2. Max minus min over 2, which in this case is 2. The amplitude is 2. What about the period? 2 pi over the period. What is the period? What is the horizontal length of one cycle? If you do it, it's from 0 to pi, so it's pi. So it's 2 pi over pi, which is 2. There's a horizontal stretch by a factor of half. Okay, we got A, we got K, let's do C. Max plus min divided by 2, so it's 3 plus -1. So you average the max and min values to find the middle. I could have told you it should be 1. Let's check. Yes, it is 1. So that's giving me good vibes there. All right, so I got A, K, and C. D, I will just extract that from the graph. So f of x equals, so be careful. This highlighting, or this red marking, shows me that it's a cosine function that's been reflected across the x-axis. So please put -2. Okay, this is not how the cosine wave looks like. Cosine starts at a maximum. That's why I said in the very beginning of this unit, you need to know how your trig functions look like, especially sine and cosine. Okay, -2, and it's cosine, and then 2x, because there's no horizontal shift. I'm still, my beginning of my wave is still on the y-axis. And then I'm going 1 unit up. Now what if I visualize this in terms of sine? Let me grab my purple pen. So like I said, you can start on anywhere on the y-axis. Oh, sorry, on the equation of the axis. So you know what, I'll sketch it in for you. Okay, you can start here, 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 or here. Okay, so there's so many points you can choose, but pick the point that's closest to the y-axis. So you can pick here or here. I'm going to pick this point. Okay, so this one's a little tricky because it doesn't follow the tick marks. So 1, 2, 3, 4 boxes is pi, then 1 box is a quarter pi. So I shifted a quarter pi. And it must be a quarter pi because the period is pi. So just like what we learned about before, the separation between key points is a quarter of a period. So if 1 period is pi, then a quarter period must be pi over 4. So everything is coming together. Beautiful. So the question is, should I let A be +2 or should I let A be -2? So I'll let you think about that, and then I will sketch in everything. Plus pi over 4 because I shifted pi over 4 to the left, and then +1. C remains the same, K remains the same, but A, the magnitude of A must remain the same. Okay, but is A positive or negative here? hopefully you look at the purple marking, the purple cycle that I've highlighted, and you see that this does not look like the regular sine wave. It goes down and then up. So this should be a sine wave with a reflection across the x-axis. Beautiful. Okay, let's do a few more. So I think 2 more, and then it's your homework. So this one I will do sine because I don't want a shift, a horizontal translation. So from this highlight, I should be able to extract the 3 parameters. I can extract A. So this one, so max is 2 minus the min is -2. So the amplitude is 2. What about the K value? So it's 2 pi over the period. This is 4 pi. Okay, 4 pi. So 2 pi over 4 pi is half. It means a horizontal stretch by a factor of 2. That makes perfect sense. It went from 2 pi to 4 pi. So you must have horizontally stretched by a factor of 2. What about C? Max plus min divided by 2. Average the max and min values. You get 0. And that's what I expected because the middle of the wave is on the x-axis. Alright, so purple. I just want to make sure I colored it correctly. Yeah, purple is sine from my previous 2 examples. Okay, so f of x equals, what's amplitude? 2 sine half x. That's it, 2 sine half x. The question is, should the 2 here be positive for a value, or should it be -2? And the answer is positive, because look at the highlighting, or look at the purple wave. It's exactly how the regular sine wave looks like. So don't make it negative. This one has no reflection across the x-axis applied to it. Okay, so let me sketch in the cosine wave. So I'll start here. And end over here. Okay. So guess what? The period remains the same. The amplitude remains the same. The equation of the axis remains the same. It's just the starting point that has changed. So it's still going to be 2. It's still going to be half. But I introduced a shift. I don't start on the y-axis anymore. I start at -pi. So I must have shifted pi to the left. And the equation axis is 0, so no vertical translation. Now, for g of x, is it positive or is it negative? Sorry, yeah, is it -2 or +2? Look at the red wave. The red wave is the cosine function that looks reflected across the x-axis. So you need to put -2. That's the most common mistake. Aside from that, once you draw it in, it's really hard to be wrong. Okay, so this one is beautiful. I love this question because no matter whether you choose to visualize this as a sine function or a cosine function, you will need to introduce a horizontal translation because the y-intercept is not a maximum point, not a minimum point, nor is it a point on the equation axis. So you have to create some horizontal shift. So I'm going to start sine first, and sine was purple. Okay, I picked the point closest to the y-axis, because y goes so far when you could be so close. But it's up to you, to be honest with you. It's really up to you. I've had students go really, really far on tests, and I've given them full marks. As long as it's right, it's right. Okay. So, from this beautiful purple wave, I'm going to extract 3 parameters, A, K, and C. So A, max minus min divided by 2, 4 minus 0 over 2, which is 2. 2 pi over the period. Ooh, what's the period here? I like this one. So it starts at -pi over 12, ends at 7 pi over 12. So the period is 7 pi over 12 minus -pi over 12, which is equal to 8 pi over 12 which is equal to 2 pi over 3. So the period is 2 pi over 3. So that means the k value is 3. C max plus min divided by 2, which is 2. As expected. You could have sketched it in if you want. Okay, you know what? I will sketch it in for you, because that will confirm the fact that this point is on the equation axis. And as a side note, when we do word problems, sketching graphs is really helpful. This is a very important lesson. If I give you the graph, you have to be able to extract the key information, and if I give you the equation, you should be able to draw me the graph. All this is very helpful when it comes to visualizing word problems. Okay, so we have A, we have K, we have C, we just need D. But we're going to extract D from the wave, from the purple wave. So f of x equals 2. We're going to decide if it's positive or negative in a second. And this is clearly sine, what is it? The period, oh, it's 2 pi over 3. Sorry, the k value is 3. Okay, so I started drawing my purple wave not on the y-axis, so there must be a horizontal shift. I started at negative pi over 12, so I must have shifted pi over 12 to the left, because that's the beginning of my wave. That's where I decided to be the beginning. Could you have chosen this point over here? Could you have started at negative 5 pi over 12? Absolutely. But I chose pi over 12 to the left, or negative pi over 12. Plus 2, that's it. So should A be negative or positive? Look at your wave. Look at what you highlighted. And the answer means, or hopefully you agree that the A value should be positive. Okay, so now I'm going to highlight using cosine. So I'll use my red pen. So I'll pick the point closest. This point's closer. So regardless of whether I visualize it as a sine function or as a transform cosine function, the amplitude remains the same, the period remains the same, and the equation axis remains the same. So since so much of the information remains the same, it's very easy to switch the equation from sine to cosine. So where did I shift? Where did I start? Not on the y-axis. I shifted pi over 12 units to the right. Okay, and should it be positive 2 for A or negative 2? And the answer is positive 2, because I started at a maximum point, which cosine does normally. And that's it. And as I was doing these questions, I realized I skipped something from the first page. On the first page, not only did they ask me to write the equation, they asked me the range. So I'll just quickly do that. So the middle is 0, amplitude is 3, so max is 3, min is negative 3. So the range is equal to negative 3 to 3. Okay, here, if you want, I'll give you a diagram here for this. The middle is 2 and the amplitude is 4. So middle is 2, amplitude is 4. So the max is 6 and the min is negative 2. Right, you're starting from middle, bounce up by 4, bounce down by 4. Really helps just visualizing it. It's just a wave, nothing too complicated. And if you're artistic, really you can just grab 2 points and you can just fill in the rest of the graph, as long as you know how the wave looks. Let's see. So this one, the middle is negative 1, and you're going up, bouncing up and down by 2. So the maximum value is 1, and the minimum value is negative 3. Draw on the picture if you want. This one, the middle is 3, and you bounce up and down by half. So 2.5 and 3.5. So 2.5. You could do decimals if you want. 3.5. And there you go. That's it. So, to summarize, the big idea for this lesson is extracting the equation from the graph. Extracting the equation from the graph. There are an infinite number of possible equations you could draw. Okay, why is that the case? Because if you look at the, for example, this graph, there are an infinite number of starting points. Let's say it's sine. You could start here, 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 and the wave just keeps going on and on and on forever. So you have infinite starting points. Now, although the equations look different, they represent the exact same wave. And that is something we did in, it was a big idea in chapter 4 with equivalent expressions. Yes, expressions might look different, but they really mean the same thing. Okay, so that could be said for trig functions. Okay, we can continue on with that idea. Yes, the trig functions, the equations of the trig functions look different, but they are truly equivalent. And we talked about that with polynomials. We talked about that with rational functions. They look different, but they're the same. You know what? Just quickly go for it. So like a polynomial, let's say 2x squared or 4x squared. See, these are identical. They might look different, but they are truly the same. So you can, this idea of equivalence is a recurring theme in high school math. So you could talk about polynomials and that idea of equivalence, and you could talk about rational functions, but I'll let you create an example. Okay, have fun.